So today's lesson, we are going to look at something called properties of logarithms. So far, we've introduced logarithms as being inverse functions of exponential functions and how to write a logarithm and how to evaluate a logarithm. So now we're going to look at what we call properties of logarithms. So here's our objectives. First, I'd be able to identify and recognize these different properties when we see them in a problem or example. And then we're going to do two things using these properties. The first is to simplify a logarithm, and then the second is to expand the logarithm. So those are really kind of opposite procedures to each other. All right, so what are these properties of logarithms? There are three of them. And the first one says, which is called the product property, that if we take the log of any base, b, of two factors, m times n, then we can break that up into two logarithms where we're taking the log of each factor separately and then adding them together, right? So this is what we call the product property. The second property is the quotient property. And what this says is if we're taking the log of a quotient, so m divided by n, we can split that up into two logarithms where we take the log of m and subtract from that the log of n, or the value that's in the denominator. So quotient property. And then the third is power property. So this says if we're taking the log of a value that has an exponent, so notice the n here, we can move that exponent to the front as a coefficient. And it would look like this. It becomes n times the log of m. And again, this works for any base value. It really doesn't matter what the base is of the logarithm. So these are the three properties of logarithms. I suggest you definitely get these in your notes, put a big box around it. And the rest of the lesson, we're just going to look at what does it mean to apply these different properties. Now, I mentioned we can do two things with these properties, either simplify or expand logarithmic expressions. So what does it mean to simplify? Simplify means to combine two or more logarithms into a single one, or move the coefficient of a logarithm to inside a logarithm as an exponent. Okay, so that's our goal if we're simplifying. When we expand a logarithmic expression, we're doing the opposite. We're expanding from one logarithm to two or more, or we're moving the exponent from inside the logarithm to the coefficient in front of the logarithm. All right, so let's take a look at some examples of this. First, we'll start with the product property. So we have log base 3 of 2 plus log base 3 of 4, and I ask you to simplify that using the product property. The key is, notice that we're adding the two logarithms, which means we're going to be able to write it as one, where we multiply the 2 and the 4 together. So that gives us log base 3 of 8. Okay, that's it. That's all it means to use the product property to simplify. All right, let's look at another one. Common log of 5 plus common log of x. We can write that as log of 5x. Let's look at a couple examples of the quotient property. And we know we're going to use quotient because notice we're subtracting these two logarithms. So log base 3 of 12 minus log base 3 of 6. So we can use the quotient property to rewrite this, where we now take the 12 and divide it by the 6. And then if we simplify, we wind up with log base 3 of 2. Let's look at another one with variables. Common log of x minus common log of y. We can rewrite that as log of x divided by y. And nothing to simplify there. Now notice, whichever we're taking the log of that's being subtracted, that is the term that's going to, or value that's going to be placed in the denominator, what we're going to divide by. All right, let's look at some examples of power property. So this is when we take the coefficient in front and move it back as the exponent. So we can take 3 times log base 5 of 2 and rewrite it as log base 5 of 2 to the third power. And then simplify, right? We know 2 to the third is 8. Let's look at one more, 4 times log of z. So we can take the 4 and move it back as the exponent. So log of z to the 4th power. All right, so there's examples of simplifying. Now, let's see if we can just identify which property is used to simplify in this case. So let's look at the first one. The answer would be quotient property. Here's how we would do it. Since we're subtracting, we're going to take log of 8 divided by 4, and that simplifies to 2. This next one, notice we've taken the exponent and moved it to the front. And so this is the power property. Here's one where we have log base 7 of 2 plus log base 7 of 6. We use the product property. 2 times 6 gives us 12. Let's look at a few more. So here we have multiple properties, right? We've done 2 things. We've taken the exponent 3 and moved it to the front. But also, since we have x cubed times y, we can split that into log of x plus log of y. So we've applied the power property and the product property. All right, let's look at another one here. Notice we've are dividing and we have an exponent. So we're going to use the power property to move that 2 to the front as a coefficient. And we're going to rewrite it as 2 logarithms. Since we have x divided by y, it's going to be log of x minus log of y. Now, what does it mean to expand a logarithm? We talked about this earlier, is to take a single logarithm and write it as the sum or difference of 2 or more logarithms. So let's look at some examples of this. We have x divided by y. So if we use the quotient property, we can rewrite that as log of x minus log of y. Or here's one, we have 2 factors, right? 3 times r to the 4th. So we actually have to do 2 things here to expand. One, break it into 2 logarithms and then move the 4 to the front. So here, let's do to the first step of applying the product property as the sum of 2 logarithms, and then move the 4 to the front as a coefficient. Notice the 4 just applies to the r factor, so it just goes in front of the second logarithm. Let's look at a few more of expanding. So we have 2 things. We've got our exponent and we're doing division. So we're going to use first the quotient property. And notice this time the exponent applies to both the 6 and the 11 because of the parentheses. So we're going to split that and apply the exponent to both the 6 and the 11. And then we're going to move that exponent 5 to the front as a coefficient for both logarithms. All right, let's look at this one. We've got lots going on. We've got 7 times m to the 4th in the numerator and then n squared in the denominator. So we're going to wind up with 3 logarithms here, right? Because we have 2 that we're multiplying, 7 and m to the 4th, and then we have 1 division operation divided by n squared. So we use that. We're going to first break those into those 3 logarithms. So log of 7 plus log of m to the 4th, since we're multiplying those 2 factors, and then minus log of n squared because we're dividing by n squared. Now let's move the exponents to the front, and we're done. Okay, a couple more examples. See if you can do these on your own. Now, G is a little tricky, right? What does it mean if we have a square root? Well, remember, we can rewrite square root as 7 raised to the 1/2 power. And now we would apply the power property and move that 1/2 to the front. Okay, so that's it. Properties of logarithms and some examples there. We know how to identify when we're applying or seeing an application of one of the properties, and we know how to simplify and expand.